Hi guys, this is my Lab 3 draft presentation, or final presentation. So the intro and purpose for this lab is to measure the distance dependence of a magnetic field of a small bar magnet, and then I'm going to write a code to assess this distance dependence and then compare the values I get from the code to the actual data values I get from my experiment. The relationships involved here are this law of natural logs and the Biot law for a bar magnet. So I have a magnetometer app on my phone, and I will set the position up of the app and the chip in my phone by orienting the meter stick so that it forms an east-west axis, and then finding the max x and finding the min x values in the intersection of those 2 points will be the location of the sensor. So I'm going to measure all these distances in the experiment relative to the location of the sensor in my phone. So from that, I was able to measure R20 through R220, so those are going to be the readings on, or those are going to be the distances, and then the readings are going to be in the column B sub x of t. And then the Excel sheet computes the average R value, and the average B sub x measured at that. And then the plot on the right is a plot of the natural log of B sub x versus the log of R. And it's a logarithmic relationship, so this makes it nice and easy to get a linear slope from the plot. So based on that, I then calculated the n value by saying the magnetic field of the bar B is equal to kr to the n power, and I know using the plot and the natural log rule that I addressed on the intro slide, I can solve for n, which is the slope of the graph, in this case 1. I am then going to use the PHYS law and the constants that I know to solve for mu, and in this case mu magnet is 0.033 ampere meter squared. And then the setup for the second experiment, this is an experiment that deals with off-axis magnetic fields. So the setup is just going to be placing the phone higher up and not on the axis of where the bar magnet is located. So you see the bar magnet down here and the phone is off axis over here. And the picture is actually taken from the side. So this would be the x-axis and this is the y-axis. And then I have the measurements for the off-axis field. I have d perpendicular, b sub y earth, and d, which is the distance, and that'll go into my code later on. I also have the b sub x, b sub y, and b sub z that I recorded from the application, and then I calculated a b net using the corrected by value based on the magnetic field of the earth, which we are given. Okay. And then I entered all of this into the parts of the code that we were supposed to customize to our measurements. So here you can see I entered in mu mag, which was 0.033 in mine. And yeah, that's basically all that I changed here. And then here you can see the function that I created for the magnetic field. So moving on, here are all the positions that my vectors will start at. And yeah, and then this loop is going to draw the on-axis magnetic fields, and that'll be the 2 orange arrows that you see later on. Here are the 4 cyan arrows that are going to show the magnetic field perpendicular to the axis. And then here's the final part that shows the magenta arrow, which is going to be an observation location 45 degrees from the axis. So once I run my code, I generate something that looks like this. So you see the orange on-axis dipoles, and then you see the cyan perpendicular dipoles, and then you see this magenta dipole at the 45-degree angle. I rotated the screen capture a little bit. So the magenta arrow here represents the perpendicular but also on axis, so it's in between a 45-degree magnetic field, and the on-axis arrows originally didn't show up as a result of the scaling factor, but I was able to fix that for this final report. And so my B at 45 degrees didn't quite match up with my experimental values. I had it on the order of 10 to the negative 5th, and here it's on 10 to the negative 7th. So there was probably some error in the formulas I used, which I kind of figured out later on as I was working through this final part. So for the post-lab questions, what if you hadn't oriented your experiment to compensate for magnetic north and laid my meter stick instead at some other kind of axis? Well, that would have, the Earth's magnetic field would have interfered with my results, so I wouldn't have been able to accurately record B sub x and B sub y from the app. And then what if I were to stick two identical magnets together end to end and run the experiment again? This is going to be a case where it's like stacked magnetic fields. So any on-axis dipoles would experience a change because of this, but any off-axis in terms of the distance from the axis would stay the same because that would cancel out with each other.